Hi students, welcome back to Physical Anthropology. In today's mini lecture we're going to be discussing the rise of Homo, and today we're looking at everyone's favorite hominin, Homo erectus. Of course I might say that about every hominin, but I kind of like Homo erectus for one particular reason. This is the first hominin to be found outside of Africa. And what this suggests is this was a very well-adapted hominin that was able to utilize the resources in its natural environment in a way that led to more advances in tool technology, to greater increase of protein and fat in its diet, and the ability to split off into smaller groups and move across the land and be adventurous. So let's get started. In today's mini lecture, we're going to be reviewing a couple things that go along with the things in your textbook. So we'll talk about who Homo erectus was and some of the anatomical differences between it and other hominin species. We'll also look at some of the fossil finds and review the tool technology that Homo erectus has been found and associated with. One point I want to make is that you need to make sure you're reading along in your textbook and don't rely on these lectures alone as a source of material. So your textbook goes into much greater detail about these different items. So in our last mini lecture we were talking about Homo habilis and the fact that Homo habilis may or may not be recognized as being two different species, Homo habilis and Homo ergaster. Well, today we're moving forward in time to about 1.8 million years ago to look at the evolution of a new species, Homo erectus, which means upright man. And the name is kind of misleading because all hominins are bipedal. But Homo erectus at this point was quite well adapted to walking upright, had a very efficient stride, and probably could have walked long distances for quite a long period of time very efficiently. Now, like Homo habilis, Homo erectus can be divided into two different species. The second species name that we'll look at is Homo ergaster, which means working man, and we'll come back to that in a minute. But let's think about what we know about Homo erectus. One of the most interesting finds of Homo erectus was Narikotomi boy, who's also known as Turkana boy, found near Lake Turkana, Kenya. This fossil dates back to about 1.5 million years ago. And Narikotomi boy is interesting because it is not an adult fossil. So in other words, this boy was not fully grown when he died. So determining the sex of this particular fossil was not that difficult, and when we get to our section on forensic anthropology, we'll talk about ways that we can determine the sex of an individual just by looking at the bones. Determining the age, on the other hand, was a little bit different. We do have markers in the bones that help us determine how old an individual was when they died, but in the case of an ancient species, determining the growth rates of the species becomes a little more difficult. So in other words, if you think about, for example, your dog grows to adulthood very quickly. It has a very short, rapid period of puppyhood, and it reaches sexual maturity fairly early. So thinking about chimpanzees and bonobos in terms of their periods of growth, they're going to be quite different than, this is my son, than these Homo erectus. And understanding the growth patterns of these hominins can be important because one thing that gets changed during evolution, right, through this change in frequency of genes or traits in a population over multiple generations, is the rate of development or the pattern of development, the way bones are constructed in the body, the way these pieces are put together during development. So modifications of development can result in changes to the adult skeleton then, or adult species. That's why it's so important to try to understand this, how these species develop, the rate they develop. And so there have been different studies to try to determine how old Narikotomi boy might have been when he died. Early studies suggested maybe he was 13, 11, and if you read in your textbook on page 305, there's now been some studies done on the teeth. And learning about the teeth, they suggest that perhaps he was about 8 years old at the time of death. But in a modern human, this tooth development might have been seen around 11 or 12. And it continues that maybe Homo erectus would have reached adulthood already by age 15. This is quite interesting. Again, we have to understand that there is diversity in the way that people develop. So I have an older son who's 11, and he's taller than I am. And I know many other 11-year-olds who are quite a bit shorter and smaller than I am. So we also have to think about individual differences in development too, and take this into consideration when we're trying to figure out populations based on a small number of fossils. But in any case, what this Narukatome boy fossil lets us know is that he was still growing, and that at his full height he might have reached between 5.5 and 6 feet tall, so that we know Homo erectus was a very tall hominin. Okay, now let's look at some of these fossil finds of Homo erectus besides Narukatome boy. The very first fossil Homo erectus found was actually found in Java, and let me show you on a map where that is. Ooh. Hey, now I'm in here twice. That's funny. Right, so here's Australia, here's Indonesia, it's this island right here. And Eugene Dubois was a Dutch doctor and scientist interested in human evolution, and he had this idea that humans maybe evolved from orangutans. So he thought if he went to the area where we find orangutans, he would likely find some evidence of extinct human species. Now, during that time, Indonesia, so when was this? Let's see, 1800s, 1890s. Indonesia was a Dutch colony, so he was in the Dutch army so that he could be sent to Indonesia and have a job and also do his sort of fossil hunting on the side to look for fossils. So he had different groups going out and looking for fossils. And what they found in 1891 was the skull cap of this individual. And he looked at the individual and he determined that it was something different. He named the species Pithecanthropus erectus, upright ape man. Eventually, we then determined that this should fall into this category of Homo erectus. So what is interesting about this fossil is, right, we find this way over here in Indonesia, which is quite far from Africa, where we found all of the other hominin species up to this time. We also have a fossil find from China named Peking man, and there's an interesting story about this particular fossil you can read about in your textbook as well. Again, demonstrating that Homo erectus is a very well adapted species and is moving quite far out of its range where it first evolved. We also have fossils in, let me see if I have a map here. Let me see, there's my map. In the Manisi, the Republic of Georgia. So if you see here on my map, here's where Peking man is from. Here is where Java man is from. Excuse me. The Manisi is at the Republic of Georgia up there, sort of northeast of Turkey. And here we have fossils dating about to 1.7 million years old, again, amongst the oldest hominins outside of Africa. Some of these fossils at the Manisi site appear to be older or maybe have some health issues, so we have some dental issues and things, suggesting that they may have lived to a longer time. And you can see there's sort of a range of sizes. They're very similar to African Homo erectus, and so this was a very interesting find. when did they discover these? Let's see. In the 1990s, and they discovered these in the 1990s. So here we have fossils found. We find these fossils of Homo erectus in Africa, but we also find them all the way over here in Java, all the way in Eastern Asia, all the way even over here into Spain. And you can actually see a nice sort of the genus Homo through time spread in your textbook on pages 292 to 293. I just changed the page number. It was wrong before. Okay, pages 292 to 293. So when we are looking at these fossils of Homo erectus, what do we notice? Well, first of all, there's this increased brain size. So the brain size of Homo erectus is larger than Homo habilis. And even though I mentioned before that the Homo species have more rounded brain cases, they're still somewhat angular, but they're definitely more rounded than the Australopithecines. So you can see it's nice and rounded, but it does have some angles, and so we say it has an angular vault compared to later Homo species, well, like compared to us, Homo sapiens. So you can see sort of in this image how they're slightly angled here. The skull is quite thick-boned and robust, so it's not delicate bone. It's still very thick, indicating that they're strong, active, outdoor types of animals, right? Whereas we are kind of indoor, wimpy animals. The skull is also longer than it is wide, so it's elongated towards this side rather than up and down. It's quite different than our skull. So whereas we have more of an up and down elongation, theirs is side to side. They have a brow ridge. So if you see here, we can notice quite a bit of brow ridge. That's a supraorbital torus. Again, torus simply means like a ridge. So they have this ridge of bone above their eyebrows. They also have an occipital torus. This is a ridge of bone in the back here, something that we don't find in modern humans. And they have a little bit of a sagittal keel. So it's not a crest on top. It's simply a little bit where these two sort of plates come together. Let me find you a picture. Okay, I found you a picture. Okay, where'd it go? Ah! Hang on a second. Okay, I found you a picture. This is a picture of Patrick Stewart, who's an actor. And if you notice, on top of his head, he has a bit of a sagittal keel. You can sort of see that his head bones are somewhat angular up towards the top there. So I'm not saying that he's a Homo erectus at all, but what I'm pointing out is that this is not completely unusual in modern humans, but our skull is definitely more rounded, so theirs would have had a more noticeable sort of keel right there at the top. Okay, so that's the sagittal keel there at the top. Now again, the other thing to think about is that from the back here, let me find my highlighter again here. Oops, go back. Highlighter, erase ink. Is that if you take the widest part of our skull, if you stick your hands together and think about where the widest part of your skull is going to be, it's going to be, I gotta put my face right here, right above your ears. And on this Homo erectus, that widest space is going to be quite a bit lower, right? So it's low across your mastoids, okay? So these are some of the features that we're going to see in Homo erectus. Another thing to notice is that they don't have a chin. We don't see chins in any Homo species until we get to anatomically modern Homo sapiens. So here's some more pictures of that same skull here, of the same, oops, let me put myself over there. Again, no chin, whereas modern humans, this is a modern Homo sapien on this side, we have a chin. You can see the distinct bony feature of the chin. They have this massive brow, whereas we do not. We have little to no brow. Our skull is quite tall, so we call this a tall vault, whereas theirs is a low vault. It doesn't stick up in the air. And as you can see here again, that the length is long this way rather than up and down. Looking at the fossils, again, we recognize that most of these Homo Homo erectus, excuse me, were quite large, and so they appear to have quite a bit larger bodies than earlier hominins. So this same chart is in your textbook. You can see Africanus here is quite small. The robust Australopithecines, again, pretty small. Homo habilis, quite small. But Homo erectus would have been larger and heavier. Of course, not as heavy in terms of body weight as us. And again, using the bones, we can also determine body weight. What else do we know about them? Well, looking at, for example, Narukatome boy, we can see that they were relatively tall and narrow-hipped, so they would have been long and linear, which would have been good in a hot environment. Most likely they had lost most of their body hair by this point, and so they were probably sweating. And now sweating is something that allows us to cool off, and sweating works most effectively when you start to lose the body hair. So we do think by the time we get to Homo erectus, we were probably hairless compared to chimpanzees or bonobos. And here at the bottom, I've included a reconstruction of Homo habilis based on a skull. So you can see the brow ridges, not too different than modern humans. Occasionally you do see a modern human with a fairly strong brow ridge, but you see that there's a low vault here. There's not a high forehead, and there's no chin. Okay. So what kind of things are these Homo erectus doing? What kind of tools are they using? Well, the tool technology we find associated with Homo erectus are the Oldowan type tools. So the oldest Homo erectus that we find in Africa are associated with those Oldowan type tools, those very simple tools made from a core, a hammerstone, and what you get when you knock the hammerstone against the core is that flake. But then around 1.4 million years ago, we start to see more complicated tools emerging, and these we call the Acheulean tool technology. So this tool technology is characterized by bifacial hand axes and cleavers. So these are very specific types of tools that we start seeing to emerge. And you see these at first among the African Homo erectus fossils starting at about 1.4 million years ago, and all the way up until about 250,000 years ago. Now together the Oldowan and Acheulean tool technologies are known as the Lower Paleolithic or the Early Stone Age. And here you can see an excavation site in West Turkana. I just want to try to include some pictures in here so you get an idea of where we're finding these types of items. So in this image here you can see we've got a hand axe, and a hand axe is this teardrop shaped tool that fits neatly into the hand, and you can use it for scraping, for example, or cutting. And this one is called a cleaver, and this cleaver has this kind of oblong shape. These are biface, in other words, you flake off pieces from both sides of the item you're making so that you end up with a sharp edge. Now remember, in the Oldowan tool technology, you simply had a core and you struck it and knocked off a flake that had a very sharp edge on it. Here you're taking a core and you're flaking off pieces to get a nice tool. Okay. Now again, the other thing to notice about here is that we have extremely symmetrical tools. So these are tools that are take a lot of work to master and take quite a bit of ability to create. Interestingly enough, this line here is called the Movius line. None of the Homo erectus fossils on the other side of this line, so the north of that side, I guess northeast of that line, have any hand axes associated with them. It's possible, you know, that, for example, Peking man, maybe he's making some sort of tool out of bamboo that would rot away, so we wouldn't have it saved in the fossil record. Or same could be happening here with Java man, but we do not find these types of tools. However, we find these same kinds of tools here in these sites that are indicated on the map here. So what kind of advantages would these tools have had over simple flakes? Well, as you read in your textbook on page 303, there's a couple different reasons these are so much more advanced and more at an advantage for them. I mean, just think about it. So because they're bifacial, they will hold their cutting edge or that sharp edge for a longer period of time. The part that has the sharpness is also longer, so allowing you to use use the tool for a larger area rather than a small piece on that tool. And really they're quite ergonomic, right? So you can use this tool without getting hand fatigue for too long. So be sure and read this on the textbook there, because it talks about some of the evidence that we have that helps us understand what they're using these tools for as well. What we really see here is quite a change in size and brain size from Homo habilis to Homo erectus. So what we're seeing is an adaptive shift, and most likely it's related to eating meat and marrow. So in your textbook on page 298 and 299, it talks about what size got to do with it. To think about how nutrition is related to population, regional differences, but also to diet. And then on page 304, your textbook author describes this adaptive shift to eating more meat and marrow. So we know that they're eating, gathered plants, and these would probably be very important for most of their diet. Just as we see gathered plants are most important for other living primates today, including us today, but we see that they're going to need a better diet with more fat and more protein to sustain this larger body and brain. Perhaps this shift in biology co-evolves with this evolution of tools. So as you begin to have culture that allows you to create these tools, this can affect your biology because you have better tools for better hunting, which allows you to eat more meat and marrow and fat, and this allows you to have selection for larger body size and larger brain size. And as you get larger body and brain size, then that's going to affect the tools you can make. So you create, you have a larger brain, you can think in a different way. It's going to change your tools you can make. It can also change your hunting strategies. So if you are able to think of different hunting strategies and increase your meat supply, again, that's going to affect what can be selected for in your population. So populations adapt and evolve to their environment, and here we also have that interplay of biology and culture that we cannot dismiss. So as they become better predators, it's possible again that leisure time would increase because you would have to spend less time eating and hunting for food. Think about gorillas. Again, they spend a bulk of their time eating and chewing their food because they eat this tough, fibrous food. As you have more meat and you can possibly even cook it, we'll talk about that in a minute, you will spend less time eating. You have to continue this low population density if you're hunting, again, to make sure you don't outstrip your resources. But perhaps as you become predators, you gain that ability to disperse. So you could follow the game as they're moving across the land, follow them perhaps into other parts of the world. So now we come to the question of fire, right? So again, one thing about modern humans today is that we cook our food, and that allows us to release the nutrients from our food so that it is absorbed more easily by our body. It also allows us to have less chewing time. So you can think about, for example, a piece of meat that is cooked nicely, you're going to have to chew it quite a bit less than a piece of raw meat. Or even like a bowl of spinach. If you cook a bowl of spinach down, it turns into a few bites versus a big bowl of salad. So cooking really changes the way we eat and live our lives. Again, the ability to cook changes our biology, which changes the way we cook. Again, we have this biocultural feedback loop. But we don't have real good evidence of fire for Homo erectus. Now, most of your documentaries and videos you might see on the Nature Channel or something will suggest that Homo erectus was cooking their food. But the truth is the evidence for this is not very conclusive. We do have some burnt earth in association with bones and things from about 1.6 million years ago. But again, it's unclear. Most of the evidence of this sort seems to be coming from sort of naturally caused fires, so like a brush fire or something where maybe things were cooked in it and things were eating. There's also been a suggestion that they may have been cooking tubers, like we cook a potato, and eating those to get carbohydrates and the bulk of nutrients. Again, but the evidence is scanty. One evidence I have here from 2012 is a burned bit. A tiny piece of charred bone was found in South Africa, dating about to 1 million years ago. And so maybe this is evidence of controlled use of fire. And I don't know if you can tell in this picture, but this burned bit is tiny. So the evidence we're talking about here to try to establish whether they actually had the ability to use fire and control it is quite small. So we do not have conclusive evidence at this time that they're using fire to cook their food, even though we have good evidence that they are eating large quantities of meat, and they have special tools for working meat and working bone and wood. Now, once again, at the beginning of this lecture, I mentioned that Homo erectus is really neat because they migrated. So they move out of Africa. All the rest of the hominins up to this point have only been found in Africa. And here we have evidence that they are able to adapt to their environment and possibly follow the herds outside of Africa all the way into Europe, throughout the Middle East, around that region, or we can call this Western Asia, I suppose, Eastern Asia, all the way into Java. Why are they migrating? Well, again, we have to look for clues at the environment and other animals. Around 2 million years ago, we get this cooling and drying occurring in Africa, which allows for larger grasslands where you have these herbivore animals grazing and moving across these large swaths of grassland. So perhaps as these animals are moving across these large grassland areas, the hominins are following them to eat them. In any case, there seems to be an evidence of technology plus that physical adaptation, the ability to walk great distances and to have hands that are well skilled for making tools, as well as a brain that allows them to create and pass down this technology. So tool technology is not something you're born with instinctively, it has to be taught. So how are these Homo erectus species that related to other species? Well, as I mentioned at the beginning of this lecture, sometimes the early Homo erectus are given a second species name, Homo ergaster, and these are usually the ones that we find in Africa, particularly at the beginning of this period. They look somewhat different than later Homo erectus, so you might see them appear here. Again, Homo habilis again can also be sort of split into two different groups, Homo habilis and Homo rudolfensis. So we have in these different charts that are on page, let's see, what page are we on? 287. You'll see different usage of different names. And what we're trying to do is understand how this family tree might have looked. So there's different suggestions based on different scenarios using these comparative method, like you saw in the film with Maurice Bloch, who was looking at plesiodaphiforms. So we're using the comparative method, comparing these fossils to other fossils, but we're also using all kinds of little detail that we glean from the environment that these fossils would have lived in. So we're thinking about the climate, we're thinking about the plants, we're thinking about the animals that lived during this time. All of that detail we have from multiple fields of study, along with detailed studies of these skeletons as well. And so there's several different scenarios that suggest perhaps Australopithecus afarensis, for example, gave rise eventually to Homo habilis, which gave rise to Homo erectus and then the later Homo species. Or perhaps, Homo rudolfensis is not part of Homo habilis. It's a separate line descended from some other Australopithecus. Or perhaps even that Homo ergaster, those in Africa, those early Homo erectus in Africa, gave rise to the later Homo, whereas the Homo erectus that moved out became extinct. So we have several different scenarios to think about. In any case, we do not know exactly what this looks like, but it's clear that these Homo erectus are within our family tree, even if we are not directly descended from them. But it is clear that Homo erectus was a very successful species, living about 1.5 million years and moving out of Africa and into other parts of the world. No. So in our next lectures, we're going to be moving forward in time to look at that transitional fossil between Homo erectus and modern Homo sapiens. I'll see you there.